Hello everyone, welcome to this session. In this session, I will explain another root finding method of real valued function called bisection method. So let's start with its definition. The bisection method is a technique for finding solutions to equations with a single unknown variable. Among various numerical methods, it stands out for its simplicity and effectiveness, particularly when dealing with transcendental equation. This is the equation those that can't be solved using algebraic method alone. This method is also called the interval Haveling method. This method is used to find root of an equation in a given interval, that is value of x for which f of x is equal to 0. The bisection method is based on the intermediate value theorem, which states that if f of x is a continuous function on the interval a, b and f of a and f of b have opposite signs, that means f of a dot f of b should be less than equal to 0. Then there is at least one root of the equation f of x is equals to 0 in the interval a, b. Here I have written the difference between the algebraic and transcendental equation. We know that algebraic equations are are the one which can be represented in the form of polynomials, like f of x is equal to a1x plus a2x squared where a1, a2, a3 are the constant and x is a variable. But in transcendental function are non-algebraic functions. For example, x sin x minus 3 e to the power x plus x square ln x plus x. This is the equation of transcendental function. This equation cannot be solved by algebraic methods only. So, this is called transcendental equation. In quantum mechanics, when you solve the step potential, then you can find the transcendental equation. Okay. Here, the two assumptions should be taken. First assumption is the function f of x is a continuous function on the interval a, b. Okay. Number two assumptions is f of a dot f of b less than equals to 0, whereas the function values at a and b should be opposite signs. Here I have written the steps for bisection method. First, first to find the middle point, say c is equals to a plus b divided by 2. Then if f of c is equals to 0, then c is the root of the function. If the f of c is not equal to 0, then f of a dot f of c less than 0. The root lies between a and c. So we refer with the interval a, c. Else if f of b dot f of c less than 0, the root lies between b and c. So here is the interval c, b. If neither of these conditions hold, then the function does not satisfy the assumptions of the bisection method. Since the root may be a floating point number, we repeat the above steps until the difference between a and b is less than or equal to very small value. Okay, I think this is clear to you. Here I have plotted a real value function, say f of x, uh, in the interval a1, uh, b1 in the x-axis domain. Okay, here this is the initial value, uh, a1 and this is the initial value b1, you see that the function value at a point a1 is positive and the at a point b1 is negative. And so the first assumptions are that the value of f of a1 and f of b1 should be opposite signs. Then we have this interval uh, and we again get a point, say f of a2 and f of b2. Then we also again have this interval, and then again and again this process will take place, and finally we get the root. Here the red dot is the root of the function f of x. Okay, here I have written the comparison between the bisection method and Newton-Raphson method. First is that the accuracy of bisection method depends on the number of iterations. The method guarantees convergence, but it has a linear rate of convergence, meaning it can take more iterations compared to the method like Newton's method, which I have previously explained in my previous video. In step 2 is the bisection method is slower compared to methods like Newton's method, but it is simple to implement, especially for functions where the derivatives are difficult to compute. Here I have written some numerical problems based on bisection method. The first question is find a real root in between the intervals 0, 3 of the following equation. Say 3x cubed minus 5x plus 1 is equal to 0. Correct up to 3 decimal places using bisection method. Store the root and the value of the function at the root and print it. I have solved this problem by using Python code, and I will show you the Python code next. Okay, here I have written 5 questions which you may solve yourself after I will show you the Python code. Okay, this is the Python code which I have written. That first, I import a Python package called NumPy. So import NumPy as np. Here I have written the inputs a is equals to -2 and b is equals to 0. And I have taken the tolerance 10 to the power -6. First, you have to define the function which I have given in the question. Here I have written the functions x square sine 2x minus cos 2x, and here I defining the bisection method def bisection. Here I have taken the function name as bisection, and this is the arguments a comma b comma tolerance. If f of a dot f of b greater than is equals to 0, that means the value of the function at a point x a and the value of the function at a point b are same, then print bisection method fails, because uh, the dot of f of a dot f of b should be less than 0. Okay, so here I have written that if f of a dot f of b greater than equals to 0, then print bisection method fails. Okay, then c is equals to a I have taken, where the c is a plus b divided by 2. Here I have create a while loop. This loop says that while b minus a divided by 2 greater than tolerance, then we have taken c is equals to a plus b divided by 2. If f of c equal to 0, then break this loop, and that means found exact root. If f of a dot f of c less than 0, then we taken b is equals to c, and else where when these two options is not true, then a is equals to c and return c. In this way we get the root of the function. Here I have written root is equals to bisection a comma b comma tolerance and print the root, and also I have printed the value of the function at root. You see that the value of the root is minus 1.305 and the value of the function as at root is minus 4.88 into 10 to the power minus 6, that is near to 0. That means that I have finding the root, this root is correct. We know that the function value at root point should be equal to 0, and here I have plotted the function by using Python package matplotlib.pyplot. So I import this package, import matplotlib.pyplot as plt. Here I have taken the x domain from -5 to 5 and taken the number of points is 100. Okay, so x is equals to np.linspace -5 to 5 comma 100. Here I have plotted this function plt.plot x comma f of x, and I have also plotted the root and the value of the root at a I have plotted the root and the value of the function at the root. Okay, so this is the plot of the function, and you say this is the x-axis and this is the y-axis, and the root lies nearly minus 1.305. Okay, in this way you can also check that the value of the root is correct or not. Okay, so I think this is clear to you about bisection method and its Python code. Thanks for watching this video.